if you want to calculate it specifically for 50, you can just put 50 in there, right? Because now you can, once you write a function like this, any problem I give you, you can solve. If it says something like, how much money would you have after 27 years? How could you find how much money you'd have after 27 years? If we do money after 27 years. I'm not going to go through and do all the solving of each of the questions I'm asking here because you know the math once we set it up. How would you use that model function to answer that kind of a question? Put 27 in, absolutely, right? Put 27 in here. 27 for that, right? Because 27 years, that's the years, right? So you'd say 1,000 times 1.10 to the 27th, right? What about if I did the other thing? This would not be hard because you would just say, well, y is equal to that. The harder question wouldn't be, how much money do you have after 27 years? What would the harder question be where you would need to use some logarithms to solve it? It wouldn't be that the money is unknown. What would it be? Yeah, like how many years is it going to take, right? How long until you're a millionaire? How long until you're a millionaire with your $1,000 in the bank? If we want to solve that, you can take your function and what are we going to do with this now? Yeah, change y to a million, right? Now I'm not going to leave this at 27. This is the unknown. You're going to substitute in the one you want and then solve it, right? So you could put a million here. I mean, I could put 10 to the 6th if I'm too lazy to write all those zeros. And I'm not a big fan of, since I'm such a hopeless one with the handwriting, of using a dot for times and then a decimal. So I'm going to put a bracket here as long as it doesn't stress you out too much. The brackets make you worried and panic. How would you go about solving that now? Because this is something we should be able to do. You're going to use logarithms. You could use logarithms right away as long as you split it up. But don't do that mistake you had before, which was thinking this x applies to this whole thing and then doing the log right away. If you're going to do the log of that right away, you'd have to say log of this plus log of this. I wouldn't do that since this is a known number and it actually works nicely with this. What would a good first step here be? Yeah, I would really think that dividing by 1,000 would be the best step here because of the numbers being so nice. So if you want to do this, you divide that, you get 1,000, you get 1.10 I lost my x here, 1.10 to the x, then you can use logarithms and figure it out, right? Then you can use logarithms and figure it out. X times log of 1.10 equals log of 1,000. Has anybody finished this and tell me how long it's going to take to become a millionaire? With $1,000? Like that's pretty, I mean, $1,000 turning into a million, that's going to take a while, isn't it? What did you get? 72 years. That's not as bad as it seems, right? It's only $1,000, but it's 70 years. 72.3 years, roughly 72 years. This should be a lesson to you. Because if you change that to 10,000, what if you change this to, not 10,000, if you change it to, instead of like the starting value, make the starting value higher, so knock off one of those zeros. If you started with 10,000, how long would it take to become a millionaire? So if this was 100 instead of 1,000, how long? 48 years. 48 years. Anyways, so go invest your $10,000 now, and then when you retire, at 10%, yeah, 10%. Which, well, if you invest in riskier things like stocks and mutual funds and stuff, you potentially can make more, but it's not guaranteed that you might lose some. But over 50 years, this is your investment advice for the day, I guess. Over 50 years, stock markets go up overall. They go like this. They go up and down, and you panic in the short term. But overall, they go up. Historically, over all the years there's been stock markets, they slowly go up. They go up and down in the short term. So if you're retiring in 2 years and you dump a bunch of money in here, you might end up there. But if you put it in here and wait 50 years, you're going to have more in the end. The key is to have long enough to earn that. Don't wait till you're 50 to start saving for your retirement. You should start earlier. Anyways, you can solve this algebraically. I'm asking you in here to do two things. Solve something algebraically and then check it graphically. Okay? We just solved that thing algebraically. We came up with a number, 70 years into the future. And we came up with, it took, I don't even know what the answer was. What was the previous one? How much money did you have after, did someone figure that one out? How much you had after, well, no, this first question I asked you a while ago, I don't think I ever wrote down the answer. How much? 15? 13? What was it? 109. We care about those cents too. 99, wow. If you want to check these two things graphically, I want you to realize for this, you can always use your calculator and graph these things and check them, right? If we want to check this, what you're going to do is you're going to put the function in. You've done some graphing before, but you likely did it not in an applied situation like this. You probably just graphed like x squared plus 3, or when you're doing straight lines or quadratics or whatever. We can put this function in and say 1,000 times, and you don't actually need the times if you use brackets, 1.10. You don't need the 0 either, of course. To the power of x. When you're graphing, you've got to use y and x. You can't use t or something else. The biggest problem with graphing on these calculators is you can't just touch the screen and resize it with your fingers like a modern device would allow you to do. You need to set up the window by giving it the dimensions. What the good thing of that is you have to think about the situation. What would be good to set up for x here, given that it's the time? And that we want to check something up to 70 years. Well, let's do the closer one first. Let's go from 0 to 30, first of all. And I'm going to make it so the scale is by 5. And we're going up to $13,000, so I am going to go up to $15,000. I'm going to go up by thousands. And I like to put a negative in here because I don't like the axis right on the bottom of the screen. I am going to put negative 3,000 here. I know you can't have, well, you can actually have negative amount of money, but it's not going to go negative for what we have. But I want to do that just so I can, on these calculators, then you can, there's a bit of space underneath it. Notice that it ramps up, right? It starts to curve up higher and higher. That's why you should invest in something early rather than later. If you wait till you're 55 and you start investing for your retirement when you're 65, all you're going to get is this. You're going to get the flat part of the curve, right? If you invest earlier, you allow lots of time. You've got to leave your money in there longer, but you allow this ramping up, and the rate you're earning money is way faster than that, right? It ramps up because you're earning interest off of interest. Key to understanding anything and being successful financially is understanding that, right? That this works for you if you're investing, and it works against you if you're borrowing or, a house or whatever, right? Anyways, if you want to check this, you can check this with a graph. Totally separate way of doing this, but you can sit here and trace and get an approximate idea. I think it's a lot quicker to go second calc if you're using this kind of calculator, or other calculators have similar thing where you can come up with a value. You just put in the number, 27. It should be that number that we had, right? There's a confirmation graphically of what we found algebraically. You can actually just put in another number. If you want 6, you just put that in. It tells you it's 6, and so on. Okay? If we want to do the reverse, this was putting in an x value and finding a y value. If you want to do the reverse of this calculator, the only way to do it is to just trace and get a rough idea. First of all, I'm going to have to change the window. I wanted to go up to it's 70-something years, right? I'll go up to 80 years. Maybe we'll go by tens if we're going up to 80 years. We have to go up to now, what do we have to go up to? Notice the difference here, right? Like after 27 years, you only have 15,000. If you wait another 27 years, your money doesn't double. It's a huge amount more than that, right? After 3 27s, you're up to $1 million already. It totally ramps up at the end. So after 80 years, we're going to have to go to like 1.2 million or something, probably even higher than that. But let's see if this makes any sense here now. Did I do something wrong there? So you don't even see the starting part because it's so low on there. Like the original values for the first 20 years here, they don't even register on here because they're so insignificant compared to $1 million. This is $1 million up here. The 1,000 we started with, you can't even see it because it's totally insignificant compared to that. But it is there, right? If you calculate the value. If we want to calculate values here, we could kind of just guess and say 72. Well, that's a bit too low. 73, that's a bit too high. You could just test it that way. The only way to truly work backwards and put in a y value is to put in a second line here and say, I want to know what it is when it's exactly $1 million. Because then it draws a horizontal line and you can find the intersection point there, which you have done before with straight lines in grade 11. Found the intersection point. If you go down here, do whatever, again, if you're using some other kind of calculator that has totally comparable features. This calculator asked for, because it's not very bright, it doesn't realize there's only two things on the screen. Like if I asked you, where's the crossing point, you'd probably go, it's right here, because you're smart. You can see there's only two things and there's only one crossing point, so there it is. It's not a very bright calculator. You say, find the crossing point, it says, what crossing point of what? And so you have to say, well, of this. And then it says, and what else? And this. And then it says, where? Just give me a hint. Where is it? Because it wants a hint. So there's only one. It doesn't matter what hint you give it because it'll find it eventually if there's only one. It'll find the closest one to whatever you guess. That's the only way to work backwards on this particular calculator. I realize if we had more sophisticated technology that costs a whopping 99 cents on your iPod, you could just do it by putting your finger there and pinpointing it. But if you have one of these calculators, it does it that way. Okay? That's a way of confirming that answer we got. We got this answer here. I may have written it down wrong over here or whatever. It's a way of confirming that. Okay? Did that actually confirm it? Did I write down the wrong thing? Is it 72.3 or did I write it down wrong? All right, 72.3 and then this is off? So log, you're telling me log 1,000 divided by... Yeah, so it's 5 here. 47. Anyways, you get the idea. You can confirm things by doing a